Okay, we are in section 2.4 and we are talking about one-sided limits. So limits we were originally talking about were a limit that's coming at it from both sides, but that's not always the case. We look at a function like this, which is a piecemeal function. The first thing you want to do is graph it because you want to get an idea of it. Now, looking at this, we can see we have the graph x squared, and you can see all these are the basic x squared graph. But that this does not exist at 1. That means there should be a hole at 1. So like A, nope, there's not a hole. There's not a hole in C. And if you click on this, you'll see it expands. They're very hard to see and shrunk down. So it has to be B or D, and I'm going to open up B. Now, what has happened here is they're replacing x equals 1 with 0. So what we're going to do is we're going to open this up, and we can see here that both these are open-ended. So that's not true because we want a function here. So we look at this one, we say, oh, that fills in the dot. So that is what this is. This function goes here. We skip this one and we keep going, but we're going to fill it in down here. So the answer is D. Okay? So now we continue on. And now this asks us to find the limit of the function coming at 1. So where we're skipping from the left side and the right side. So let's open this up so we can talk about this. So you can see we're coming in this way and we're coming in this way. Now remember, we never get to this. That's the idea of a limit. So both of these are coming right here at this. And what is this? This is 2, 4, 6, 8, 10. So you can see this is actually right here at 1. And we're never quite going to get there. So both these sides are approaching 1. So it doesn't matter that this is down here and that this is empty because remember the limit never gets there. So both of these are coming in to 1. So here, I'm going to close this, A, and our answers are 1 and 1. Check the answer, and that's the right answer. Now we're going to continue on. Now, does the limit of 1 exist? So the limit of both sides exists. We just did that. Now the entire limit exists if both the right and the left side limits are equal. Are they equal? Yes. So it does exist and it is 1. Check the answer, and that's true. Now you might go, well, it's not there. It's down there at 0. Well, it happened. Well, remember, the limit never gets there. So it doesn't matter that they've pulled this out. That's the basic definition of a limit, that it never quite gets there. Since it never gets there, it doesn't matter to us that that is actually down here at 0. So this does exist. Now, if these had been different, this has been 1 and this has been -1, it would not exist. So this exists because these are the same. They're coming into the same point. It doesn't matter that they never get to that point because that's what a limit is.